Good morning and welcome to the Q&A session 5 from the playlist of Dual Nature of Radiation and Matter. The topic for the today's session is emission of photons, and based on this topic I have one question for this session which is written here on this board. So the question here is, find the number of photons emitted by a sodium lamp of 10 watt if 90% of the consumed energy is converted into light. And here the wavelength of the sodium light is equal to 590 nanometer, and the value of the Planck's constant is to be taken as 6.63 into 10 to the power minus 34 joules per second. So in order to find the number of photons emitted, we will first of all find the energy of a photon, which is given by the formula, that is E is equal to hc upon lambda, where c is the velocity of the light in vacuum, h is the Planck's constant, and lambda is the wavelength. So from here, the energy of the photon will be equal to 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 meter per second divided by lambda, which is equal to 590 into 10 to the power minus 9 meters. This is in nanometer. The wavelength is given in nanometers, so I have converted this into meter. So the energy of the photon here, the unit of the energy of the photon will be in joule, because see here the unit of the Planck's constant is joule second. The unit of the velocity of light is meter per second, and the unit of the wavelength is meter. So from here we will get the unit of the energy of a photon in joules. So the value will be equal to, the energy of photon of a photon will be 6.63 into 3 divided by 590 into, now this 10 to the power 9 will go in the numerator, so it will become 8 plus 9, that is equal to 17, minus 34 plus 17 will be equal to 10 to the power minus 17. So E is equal to, now this 6.63 into 3 will be equal to, this is equal to 19.89 divided by 59, and this will be equal to 59 into 10. So I can write this value as 10 to the power, this is minus 17, so 10, if it is taken in the numerator, this will be equal to 10 to the power minus 1. So I will be getting the energy of the photon as 19.89 divided by 59 into 10 to the power minus 18 joules. Now here the 90% here this the wattage of the sodium lamp is 10 watt, and 90% of the consumed energy is getting converted into light. So energy of light the energy of the light emitted will be equal to 90% of 10, which is equal to 9 watt. Now 1 watt is equal to 1 joule per second. So the energy of the light emitted per second will be equal to 9 joules. Energy of light emitted per second, this will be equal to 9 joules. Okay, now here the energy of a photon, this is the energy of a photon, which is equal to 19.89 divided by 59 into 10 to the power minus 18 joules, and the energy of the light emitted per second is equal to 9 joules. So the number of photons emitted per second this will be equal to 9 joules per second, 9 joules divided by 19.89 divided by 59 into 10 to the power minus 18 joules. So this is equal to 9 into 59 divided by 19.89 into 10 to the power 18. So this is the number of photons which are emitted per second. So this will be equal to 59 into 9. This is equal to 531 divided by 19.89. 531 divided by 19.89. This is equal to 26.7 approximately. This is approximately equal to 26.7 into 10 to the power 18, or simply we can write this as 0.267 into 10 to the power 20. You can just simply divide this by 100 and multiply here by 100. So you will get the value as 0.267 into 10 to the power 20. So the number of photons emitted per second will be equal to 0.267 into 10 to the power 20. And here we have been given 4 options. So out of these 4 options, the correct option is A. So thank you very much for joining this session. In the next session, we will continue with the same chapter, that is the dual nature of law of radiation and matter. But the topic will be different. So till then, have a nice day. Bye.